try to share with you some ideas and experiences in the description of research workflows and digital data sets with a special focus put on traceability. Okay, I have to be more closer. Traceability, reproducibility, and comparability. I will illustrate my point with the. You don't hear? I'm too close or too far away? I have to be really close to it. Okay. So I'll talk about traceability, reproducibility, comparability issues related to description of research workflows in digital datasets. I will illustrate my points with spatio-acoustic data acquisition protocols. So when we try to describe how we manage to achieve a result, for example, digital data set, not digital at all, first of all, we have to choose the language to be used. Quite often we use ethnic languages, English, French, Italian. Ethnic languages have these particularities that are situated somewhere, they fall somewhere in between hard languages that are context-free and that where the level of polyinterpretation is absent or very low, and the soft languages that are strongly polysemantic, where the meaning is highly subjective and context-dependent. Okay, so if we want to ensure reproducibility, comparability of the workflow description, we should try to reduce the possibilities of polyinterpretation of the description. How can we do this? We can do it through conceptual modeling, controlled vocabulary, or diagrammatic representation. Why diagrammatic representation? Because when we use them, we use rather visual thinking that is language independent. So these are the bases on which the Memoria experimental information system based on. My presentation will be summarized in 4 points. First, I will give you a brief introduction to our research objectives. Then I will start to present some underlying basic concepts, and I will illustrate them by the means of examples. Finally, I will present the advantages and the limits of this approach. So Memoria is an exploratory web-based information system built to address the burning issue of traceability, variability, comparability, and reproducibility of research results and protocols. It aims to provide practical solutions for formalizing and describing research workflows. What are the main objectives? The system should allow us to identify, structure, and preserve information about different types of research results with their metadata, and to identify, structure, and preserve information about the sequences of actions that led to their creation. Such a workflow can be described by purely verbal means, but we have decided to depict it using a diagrammatic representation combined with paradata, and we'll call it Memoria workflow diagram. This diagram is a sort of graph where the nodes represent activities and the connections between them represent time-oriented relations between activities. Activities may be organized as a chain, showing the order of the activities. Some sequences of activities may run concurrently in time. Activities may be combined. It means that they take place simultaneously or they occur without any apparent sequential order. Iteration is another type of temporal relation, and it differs from the repetition. So each node of the diagram represents an activity. Its color refers to one of the 5 groups of activities. Data collection and acquisition is red. You see, it's mainly red. But there are some elements that are yellow, data analysis, or green, data filtering and treatment groups. Within each group, activities are structured, defined, and exemplified. They result from successive knowledge elicitation steps. It means that activity structure can be enriched. So activities are organized in the workflow diagram using a drag and drop web interface as illustrated here. If it wants to work. Okay, the first step is identification and selection of activities. Then we can position activities within the grid. And finally, we define relations between them. And we can identify the moments when the results appear. We can also point out the other preceding processes. The next step is a description of individual activities, activity by activity, by identifying particularities of this particular activity using controlled vocabulary. And we can add also some free remark and comments. Once the activity is characterized, background color is added to its icon. So a workflow diagram structures, organizes sequences of activities together with the paradata. It is a sort of a backbone of the body of the process. Paradata, organized by the means of a workflow diagram, are stored within the database. So they are freely accessible, searchable, editable. They can be queried, compared, and visualized. Here we have two examples of the workflow diagrams representing acquisition protocols, acoustic and spatio-acoustic data acquisition. You can easily notice the differences in their complexity, in their structure. You can see different groups of activities that are present in those processes. But the difference is even more striking if we take the processes behind the results of different nature. One more example. Now to exemplify the approach, I will focus on this spatio-acoustic data acquisition protocol. What are all those people doing? Who works with whom? It is in fact difficult to say because people are doing different things. Maybe it's even hard to believe, but they do it in an organized way. However, some actions are planned and some are spontaneous. What you see here is one single interdisciplinary acquisition protocol made of numerous actions, including instrument positioning, acoustic data acquisition, metric and visual acquisition, and of course, documentation. These actions may be expressed in the form of memorial workflow diagram that can be used to fix the order of sequences, activities corresponding to different phases, for example, instrument positioning, documentation, acoustic data acquisition and processing, laser distance measurement, photogrammetric acquisition. Such a diagram allows a context view. You see all the process and the relations between the activities, and it allows also a focus view on the particular activity. The same data can be visualized in different manners. On the left-hand side, you have a process represented as a workflow diagram. On the right side, the same process is depicted as activities proportion ring that is called sometimes bonhomme d'activité. The visualization This visualization displays what are the relative proportions of each group of activities inside the process. It shows a number and types of results and inputs. We have also information about all instruments that have been used, all softwares, dates, and things like that. The same data within the process variability code diagram visualization are exploited to display relations between processes conducted within a given project. You have the process, project A, project B, different processes, different relations. Here there is a project C. Now I pass to the conclusions. We think that this documentation framework may enable traceability of results, verifiability of research protocols, comparability and analysis of individual processes. Reproducibility of results is another question because it does not depend only to the quality of the workflow description. Some results are simply not reproducible. So the system may be used to support planning of the research protocols based on the past experiences, whenever they are interdisciplinary or not. We can use it as a tacit theoretical knowledge sharing environment, targeting education or research communities. We can try to develop more this tool and use it as an analytical framework. And I think that by requiring careful thinking, this sort of framework can help us to work more efficiently, more consciously, and less routinely. The limits that I will mention today are divided in two groups: acceptability, human acceptability, and technical constraints. Memoria remains the human-centered system. Therefore, we should not forget that the quality and reliability of visualization depends strongly on the data that are entered by various individuals. Documenting is always time-consuming. In this case, we need to learn the language, the logic of the system, and we need to gain some confidence in using it. This learning curve may be more steeper for some than for others. And the last point is the question of our readiness to openly share information with others and the extent to which we want to do so. The technical constraints are simple. I think that everybody knows them. They are related to problems of sustainability of web information system, costly, complex development steps. We have some future works in mind, and I will be happy to discuss them with you later on today. Thank you very much. Here you have some links, useful links if you are interested in this project.